one more little video for the semester. But I don't think it looks too great with the screen here. Yeah, I want to help you with some homework. And one of the things, so we learned about, a lot of this is investing the money and in 5.5. But we learned about this formula for investing money kind of early in chapter 5. And again, the phrase here is if the interest is compounded continuously, then this is our formula. By the way, you don't have to memorize this formula. I think on test day I'll write it on the board. But what I won't write on the board is this little note here. I'd like you to know that. So if it's compounded continuously, there's your formula. I'll write it on the board. And then the new formula, though, that was in 5.5 quite a bit, was when it's compounded certain number of times a year. So there's the interest rate. You divide by k, and you raise it to the k times t. And k is, this is when the interest is compounded k times per year. So we practiced this a little the other day. All right, I lectured you on it. If it's compounded k times per year, like if it's compounded monthly, k is 12. Good job. If it's compounded daily, k is 365. If it's compounded yearly or annually, they say, that's once a year, k is 1. So, right. So there's these two formulas that for investing money, and it earns interest, and we watch our money grow. Here, let's try a homework problem here. I'll just start like I do. I start the hardest stuff is usually at the end, so I'm starting there. And here's a question. I don't think I need to watch the video. Here's a question. If 90,000 is invested at 6% compounded annually, find the future value in 9 years. I guess that's kind of what we're calling this S, the future value. It's what the money grows to. You start with this amount of money, and then it grows to this amount of money. So this one's kind of easy. If it's compounded annually, which formula am I using? This one. And k is? 1, which is really easy. Right, when it's compounded annually, that's my main thing, man. I got to read the words and realize k is 1. I'm going to just try this one real quick. So S is 90,000. Is that what it is? 90,000. 1 plus the interest rate. I guess the interest rate is 0.06. 0.06 divided by 1, which is kind of stupid, and that's 0.06. But raised to the k times t, but the k is just a 1, so then the t is the 9 years. So really, you know, again, this is kind of a cool formula. It's kind of a complicated formula a little bit, but it's not too bad. But it boils down to this, 90,000, 1.06, that's what that is, raised to the 9th. I mean, you know, it looks, when it's all said and done, it kind of looks like all our exponential functions kind of look. A base raised to a power multiplied by a number out front. And now you need your calculator skills. Again, on Tuesday's test, you can't ask me to help you with your calculator. By then, you should know how to use your calculator. So can you find your exponent button? Can you raise this to the 9th? After you raise it to the 9th, can you multiply by this? And the final answer is...
$53.11.
All right, thank you. Now, I'd like somebody to tell me an answer like he did, and then I'm waiting for the rest of you to check it out. I mean, again, y'all can practice this. You can go home, practice it later, or practice it right now while you're sitting here, but you ought to, can you do it? Can you pick up your calculator and do it? So cool. Anybody else get that answer? All right, cool. Then it's the answer. Yeah, it's easy, man. I mean, you know, this chapter's got a lot of new stuff, the e's and the logs and the, you know, some complicated looking word problems, but I tell you, students, you can do good on this chapter. I mean, it's not that hard. You got your calculator, you know how to use it, and you get these formulas, and I don't know. You can do well in this chapter if you practice it. Let's try something else. Let's try something else. Yeah. This is pretty good stuff right here now. This is a good problem. I think this time, instead of, this is a little more complicated, well, let's read this. What I like to do is I like to skip to the math and skip some of the reading, and that ain't cool. I mean, you guys, you might try to do the same thing. It's, you should read it. So, at the end of T years, the future value of an $11,000 investment, it earns 6%, compounded monthly, is this formula. So anyway, that's nice of them. They're giving me the formula. That's my original amount of money. They said it's 6%. They said it's compounded monthly, so K is 12. So they're dividing by 12. And then up here they got the 12, because that's the K times T. Now what they don't know is how long did they leave it in there? What is the time they left it in there? Well, let's see what the question is. The question says, how long will it take for this investment to reach $55,000? So see, this is a backwards question. Now they're asking me for the time it takes for this to reach $55,000. You know, on your quiz we took the other day, some of you struggled with that question. When I gave you the money and asked you for the time, you kind of struggled a little. This one's even tougher. So I'm saying that what this problem wants is the S to be the 55,000. Is that what you figured out? This is 11,000. I'm going to work on that if you don't mind. What is the 0.06 divided by 12? The 0.06 divided by 12. It's easy. I think it's 0.02. Is that what it is? Or 0.00? Oh, it's 0.05? Yeah, sorry. Okay, all right. All right, thank you. The 0.06 divided by 12 is 0.005. When you add it to the 1, then you have 1.005 raised to the 12t. And now you're supposed to solve for t. So this is a good problem. I practiced this a few days back. This is a good problem. You're supposed to solve for t. Any suggestions? I like that. Divide by 11,000. You have to get the base. You have to expose the base. So yes, you definitely divide by that. That's nice. That's a 5. And then this is 1.005 raised to the 12t. So I'll do more work today, and you'll see what different types of work I do today. But this is one of the toughest ones right here off the bat, because, listen, if this was base E, I think I would log both sides, ln both sides to get rid of the E. If it was base 10, I think I would use log base 10, and that would get rid of the 10. But when it's this funny base, then I have a different strategy. I taught it to you last week or so, and to tell you the truth, my strategy is not to cancel the base.
Right.
Because I don't want to use a log base 1.005. I don't want to do that. So I want to just use ln, to tell you the truth. But it doesn't cancel the base. What does it do? Watch. If I do the ln of both sides, then I get the ln of 1.005 raised to the 12t. Again, this ln is not canceling this base like in some problems. It would if it was base E. It would if it was base E. But it's not canceling the base. So what the hell am I doing? Well, I'm going to use that special log property that says once you introduce a log on both sides, you can take this exponent and write it down front. Remember that log property? That's what I need. I need that log property. I mean, this is what I need to get t down and solve for t. It's a different strategy. It ain't about killing the base. It's about introducing a log so you can use that log property to get that down. So now I have this. The natural log of 5, and don't freak out, dude, it's just a number. It's just a number. Equals 12 times t times this ln of 1.005. And again, don't freak out. That's a number right there, you guys. And 12's a number. You got a couple of numbers multiplied by t. How are you going to solve for t if you got some numbers multiplied by t? You're going to divide by those numbers. Thank you. They're just numbers, and you're going to divide by them. I always pick up my calculator last, so I'm not doing any calculator work until the end. By the way, that's just a number. it equals 12 times t times that number. So to solve for t, I want to divide by 12 and I want to divide by that number. So t is this natural log of 5 divided by the 12 and the ln of 1.005. And maybe if you're going to type this into your calculator, to tell you the truth, maybe you need this whole denominator in parentheses. I want all that in the denominator there. So, or you can do it in little baby steps. Type this in your calculator, get a decimal. Type this in your calculator and get a decimal, then divide your decimals. You can do it in baby steps. You can do it all in one step. It depends on you and your calculator skills. But I'm looking for an answer now. 26.89. They do want 2 decimals. This is the number of years it takes for my investment to grow. And he just said it's 26.89. I kind of prefer 1 decimal when it's years. But anyway, they asked for 2 decimals. Now, did anybody else get that answer?
Yes.
All right. Good job. If you're having trouble getting that answer, maybe you need parentheses, maybe you need to figure out your calculator work here. I am using ln right here. But this is one of the more sophisticated problems. Again, if I tell you to solve this equation, you're just trying to kill the base e. And I would use an ln. And then you have the ln of 8. And over on this side, when you do the ln of e to the t, the ln and the e cancel each other out, and you're done. There's the answer. I mean, this was kind of an easier version of solving for t. Because my base was a little weird here, I had a different strategy. It's not about killing the base. I still use the ln, but it's not about killing the base. It's about bringing this exponent down front. Sort of a different strategy for solving. It's cool. It's cool to understand all that. And that's the point. That's why I'm up here talking. That's why you're there listening. Yeah. You can interrupt me if you got a question. You guys all right? I'm going to move on. I'm not even going to bother typing it in. I think I'm right. I mean, that looks kind of easy. I think that looks kind of easy. Let me see what else I got here. That's kind of easy. I mean, this time, these are a little easy. This one was tough. I had to solve for t. And this was the game. This is easier. What is this? It says I got 3,000 invested, 6%, compounded continuously. You got to look for the little word. That little word tells you use this formula. And then I don't even think I'm solving for t in this one. I think I'm just plugging in. Let's see how easy this is. I think I'm looking for s. I think I got $3,000. E raised to the 0.06. And it says I'm going to leave my money in there for 4 years. Is that what it says? Well then, this is multiplied by 4. See, sometimes I write it, I put the parentheses like that. It's 0.06 times the 4, just so you can. But the truth is, all that is kind of in parentheses. It's all being e'd. So you e that number, then you multiply by 3,000, and you're done. You're not solving for t this time. Anybody want to tell me how much money it is? 4 years ain't gonna be too much. $3,000, 6% interest, 4 years. Not gonna be too much.
3,813 and 75 cents.
All right, say it one more time.
3,813 75 cents.
Thank you very much. Is that true, you guys? Thank you, thank you, thank you, thank you. Here, you gotta find your E button. Use your E buttons. Here, this might be a damn easy test. You might get all hundreds. Well, this is only, maybe we should do this one. It's the same old thing over and over again. Little twists and turns, though, make it different. Again, those two formulas, let's get rid of this stuff, I guess. 2,000 and is vested at 11% interest, and this time though it's compounded daily. So the first question is, find the value in 6 years. All right, here I go. But if it's compounded daily, it ain't this formula. I like this formula. It's easy. This is an easier formula. Okay, this formula is a little tougher with the K involved and stuff, but it's going to be this formula. And what is K? Bless you. 365. So here I go. Let's see. The original amount of money, $2,000. $2,000. 1 plus, what's the interest rate? 0.11, right? 0.11 divided by 365, all raised to the 365, because that's the K, times T, which is the number of years you're doing this. 6 years. Times 6. All right, so I got some advice for you here. This is going to be kind of nasty. The 0.11 divided by 365 ain't pretty. Let me try it. The 0.11 divided by the 365 ain't pretty. In fact, I'm getting 3.01 times e to the negative 4. It's scientific notation, which pisses me off. But you know what? What am I about to do with that number? What am I about to do to that number now? Add 1. So just do that on your calculator. If you add 1 right now, it'll look a little better. Oh, yeah, good. Now it's not in scientific notation. It is 1. This base became 1.00030137. And my advice is do not round it off. Did you hear my advice? Don't round off this base, because it's kind of crucial to it really changes the outcome. Well, I know it's a nasty long decimal, but I kept all my decimals. And what am I raising it to? What am I raising this to? Holy shit. 365 times 6. That's 2190. Thank you very much. So now, my calculator might start smoking. I need to have this base raised to this exponent. When you're done, please multiply by 2,000. You with me? And again, it's kind of a calculator exercise. I don't know. It's an exercise in using this formula and then messing around with your calculator with a little advice from me. I'm raising this to the 2190, and I get a number. I get 1.93 something. I'm just going to go ahead and multiply by 2,000 though, and here comes my final answer. 3869.20 if you round it to the correct pennies there. That's pretty cool, huh? Yes, sir.
How many weeks are in a year again?
What'd you say?
Weeks in a year?
52, sort of, but it ain't exact. It's 52 and a half, or 52, it's not perfect. That was fun, huh? Hey, look at this next question. This was compounded daily. The next question says, determine whether more or less money would have accrued if it had been compounded quarterly. And maybe you realize that compounded quarterly is only once every 3 months, and compounded daily is every day. Which one gives you more money? The daily. Yeah. When you compound it more often, you'll end up with more money. The truth is, it won't be that much more money, but it will be more the more you compound it. The more frequently you compound the interest, the more you'll end up with more money. So, that's right. I love doing homework. That's similar stuff, same old stuff here for a little bit. Again, I'm going backwards through the homework, so bless you. Here, this is the beginning of the homework, and they're actually giving me the formula, and they're giving me the numbers. They're just kind of making me practice plugging them in. what's a little funny is instead of t, they're using an n for the number of years. I use t for the time in years. That's okay. They're just making you practice using the formula. All right, that might be enough of that. Let's see. I might want to go to 5.4. That was the other section I lectured on the other day. Let's go there a second. Okay. All right. So these are our financial formulas, I guess. But for our exponential data, and then maybe, I told you the other day, to try to find a formula for exponential data, we kind of need this. And then, you know, A is sort of the starting number, or the y-intercept. We talked about this the other day. And then B is the base. And the base is the thing you multiply by every time. And sometimes you can look at some data and figure that out, or sometimes it's hard to figure out, but you kind of need a starting value and a base. You know, I've outlined this before. But what's coming up in this problem is a funny idea that I didn't get to the other day. Sometimes that base is either 1 plus r sometimes, or 1 minus r sometimes, when r is some kind of a growth rate. Well, hang on. In this case, r is a growth rate. In this case, r is a decay rate. See, we had this discussion again 2 or 3 days back, not 3 or 4 days back. We had this discussion where I said, you know, if something is increasing by 12% every day, then you can multiply by 1.12. If it's increasing by 12%, you can multiply by 1.12 to see what it increased to. Then if it increases 12% the next day, you can multiply by 1.12 again. So if something has a growth rate of 12%, it's 0.12, your base is 1.12. And that's the thing you multiply by every time. And then we said, if something was being discounted or decreased 12% every day, you take 12% away from 100%, or you take 0.12 away from 1, and you have 88%, or 0.88. And so if something is losing 12%, it's retaining 88%. Anyway, the base is 1 minus 0.12, or the base might be 0.88. And you multiply by 0.88 every day for something that's losing 12%. You with me? We had that discussion. It's common sense in a way. It's a little mathy. You got to think about that math for a minute. But anyway, we might need that. And that's what's going on in this problem, I think. And oh, by the way, they were nice enough to sort of explain that to me. See, look what they're doing. They're telling me my base is a 1 plus r. Why are they telling me it's a 1 plus r? Because they're saying it increases at 3% every year. It starts at 22,000. Again, this is how when I read the important parts. And I don't read the whole thing sometimes, which can get you in trouble. But I think I figured this out. And all they want is the equation here. So I think my equation, if something's increasing at 3%, I think my base is, what do you think it is? 1.03 raised to the t with an initial value of 22,000. You following me? I want to say something. If they happen to use the word continuous growth rate, that makes me... They didn't use that word, and they wanted me to do this. But if it's a continuous growth rate, that tends to make me use that E base. And then if it was growing at 3%, watch me, I'd put a 0.03 t here. And 22,000 here. I mean, this is different. This is not the answer to this. And it's not a choice. But there are some problems where they, I don't know, our book might not do it like that. Different books have done it different ways. I explained this for 20 years. I explain it different ways at times. You may not run into this. Or if you did, they'd give you the formula. But this would be a continuous growth rate of 3%. This is more like every year. Like during the year, it didn't do nothing. But at the end of the year, it went up 3%. But during that year, there wasn't continuous growth. Which is kind of bullshit. I think it would kind of be continuous growth. Anyway, it's okay. Cool. What did we do? Did we decide the answer is this? Something that grows at 3%? That's the equation. Right. What else? What else? Same kind of thing. Same kind of thing. What's this one doing? Oh, decrease by 5%. See that little word decrease? Well, you can't see it. Sorry. It starts at 16,000 and it decreased by 5%. Can you come up with the equation? Starts at 16,000, decreases by 5% every time. I think that's my base. I think that's it. So that answers part A, and then I'll just click that. That should answer part A, and then part B says 7 weeks later. What is it? And so is this this is happening each week? Yeah, it's decreasing 5% each week. So my X is in weeks. And I guess to answer this second question, I would plug in a 7. Are you with me? All right. I won't even bother. Plug in a 7. Do the math. Right. Cool. Here's another one. Yeah, same thing. Cool. Let's see what else we got. Uh-oh. All right. I warned you the other day that up in 5-4, there might be some problems you can't do. You know, like your teacher might have made an error. God forbid. And I think this is one. Look, what I tried to teach you the other day that when you have a chart of data, that you can find the base if you figure out what do you multiply by every time? What do you multiply those y values by every time? And so, what do you multiply this y value by to get this? 3. You see it? It's a 3. You multiply by 3. Okay, so you multiply by a 3. All right. Well, guess what? that doesn't remain constant throughout this problem. If you multiply this guy by 3, it shouldn't be 14. It should be 18. So to find out what you multiply by, I told you that to find out the base, which is the thing you multiply by, I told you that one way to calculate the base is it's the next y value divided by the previous y value. Now this is just second grade math, maybe third grade, sorry. If you're trying to figure out what you multiply by to get this, you divide to figure out what you multiply by. So I'm dividing the next y value by the previous y value. So help me out. What's 14 divided by 6? 2.3 repeating. Okay. So help me out with the next one. What's 36 divided by 14? So the thing I multiply by is 2 point what? 5.7. All right. And then one more time, please. 87? All right, so look at these numbers. So the base is not constantly perfect. And so I can't really do this problem. 2.42. Oh, 2.42? Thank you. The base keeps changing. Now it's roughly around 3 or 2.5 or, you know, and a calculator or a computer could take this data and it would roughly average these somehow. Not a real average, but some type of average. And it would come up with the best fit base. And it would be some type of average. And I'm trying to explain that you can't do this problem. You're going to have to get this one wrong. So if you've had 100% on all your homework, it's shot right now. It's shot. Sorry.
Darn.
It's going to be all right. I think it'll be all right. It'll now be, if you had 100, it was going to be 99.99999. It ain't going to be 100 anymore. You're going to miss this question. Oh, unless you get lucky. Is there a way to click through it and get lucky? Maybe not. I don't think, I mean, on this one, I think you got to, look, see the GC? It means graphing calculator. It means you feed this data into a calculator or into a computer using an Excel program or something, and you click the right buttons and the calculator tells you the answer. So, we can do it. Cool. Your teacher made one mistake. Maybe two mistakes. Here's another one we can't do. No. Look, this data kind of sucks too. I don't like this data, but this question is different. They didn't say come up with the equation. They said come up with the graph. So you could plot these points. You could actually find this graph, I think. You just kind of plot the points, right? You just kind of plot the points, pick the right graph. I don't know. This is definitely linear looking. This is kind of, I don't know. This is kind of subtle. All these are darn close in a way. But 1 is 8, 2 is 10, 3 is 11.7. This kind of looks like it right here. Don't you think? I'll just check it, see what happens. Woohoo! You never know on yours. Oh, does it appear that this is exponential or linear? Yeah, that's a good question. Looked pretty damn linear, didn't it? I mean, there might have been a little curve to it, but it wasn't very curvy. I might call it linear. Wonder what they're going to say. Woohoo! All right. All right. Hang on, I'm trying to work backwards here. Ooh, yeah. All right, here's another one. This one is perfect exponential data, I think. Here we are again with some data. What do you multiply the y values by every time?
4.
Multiply by 4. Multiply by 4. Multiply by 4. Multiply by 4. It sure is. It really is a 4 every time. So the base is 4. So the base is 4. So now my only little worry is what's the starting value? And the starting value is the y-intercept. It always goes with x equals 0. And god dang it, they didn't put x equals 0 up here. I think I would do that if I was writing the question. That's what I did the other day when I did these examples. I put 0 in the problem to make it easy for you. But they didn't put 0 here. But you know what? Every time x goes up 1, we're multiplying by 4, aren't we? Well, and if I want to go backwards 1, maybe I could divide by 4. So if I wanted to go back to what I think is 0, then I would divide by 4 and get a 1. And I think that's my y-intercept. So I just figured it out. So the equation would be a 1, like when it's a 1, you don't write a 1, times 4 to the x. That's all it is, right? A base of 4 and kind of no number out front or a 1 out front. You know? Cool. You guys okay? Again, you can interrupt me. Here's another one. Again, they're not really wanting me to calculate anything. Look at down here. Is it exponential or not, or exactly exponential? And this is some bad looking data, ain't it? Look at it. I mean, you go from 2 to 6. That could be interpreted as exponential if it kept up that consistency, which is multiply by 3, multiply by 3, multiply by 3, but it ain't. Then it goes from 6 to this, then it's 9, then it stays at 9. And this is just not exponential, if you ask me. Not even approximately, you know what I'm saying? I don't think it's exponential. All right, that's enough of this. That was 5-4. I could go to 5-3. Let's try something at 5-3 maybe. Let's see. Yeah. Okay. This is good. And again, sometimes, so we're back in 5.3, and I don't know, the theme of 5.3, I think, was solving equations. And we started that, almost kind of started that today at the very end of 5.5 there. But when you read this, it's a scary sounding scientific word problem, but the math is not really that hard. We got some kind of a radioactive isotope, and the amount is this amount, and it looks like it must be decreasing over time. But so what's the question? How long will it take for the amount to equal 516? So what do you think you do with this problem? Stick in 516 for the y value? I think so. Or the amount, or what I'm calling the y value over there. You stick in 516 for that and try to find out how long. See, when they say how long, that's time. So they're looking for the time t. E to the negative 0.028271 t. You following me? I mean, maybe you can't read those little numbers, but now maybe you can. It's just an equation for the amount of a radioactive substance, and their question is, how long will it be for the amount to equal 516? That's what it was. Now, can you solve this? I think so. Although, this is the kind of thing, this was on your quiz Tuesday when you had to find out when my money was $1 million. Some of you kind of, I mean, that was a little place where you broke down. You should set it equal to 1 million and solve this. Also on the back, when you're looking for an x-intercept, you set something, you know how to look for it. You set something equal, you solve these kind of equations. You should be able to solve these. What would you do? Divide by 800. Divide by 800. See if you can give me a decimal for that. What is 516 divided by 800? 0.6?
4.5.
4.5. Thank you very much. She divided that and got this. Sometimes I divide at the end, but that's okay. It came out nice. 0.645. Now what? Oh, that equals this e to the negative 0.028271 t. Now, how do you get rid of an e?
ln.
You ln both sides. It's so easy and beautiful. You ln both sides. You ln this number. And when you ln this number, it cancels the e, and you're left with negative 0.028271 times t. Now, how do you solve for t? Divide by that number. So this is the little game here. It's not a difficult game. But you got to understand a couple moves. You got to understand the concept of undoing the base of e using a logarithm. A natural logarithm undoes the base of e. I guess that's what you got to understand. One more move, I'll divide. And so my answer is that natural log of 0.645 over this nasty little negative 0.028271. That is the answer. And I would pick up my calculator and try to do this. You know, I think that answer is going to be negative. When my calculator does it, it'll be negative. It'll divide by this negative, resulting in a positive answer of
15.51.
Thank you, 15.51 years. That's the idea of radioactive stuff. It decays, but it kind of never goes away. It kind of slowly decays. It will take 15.51 years. Round to the nearest whole number, they said. Okay, they got different rounding rules. So maybe I'd call that 16 years. You guys okay?
Mm-hmm.
That was kind of easy. Solving an equation. I mean, again, it sounded like a scary word problem, but it was fairly simple solving, I think. Yeah, same kind of thing here. You can read all that if you want to, but basically you're going to solve an equation. Ooh. This is complicated. Look at the problem. Let's see what this says. Again, all the words kind of scare me. Do words scare you? I'm a math guy. Well, I don't like them words. I don't like nothing to do with no words. No, I'm kidding. But you gotta read these words. A minute ad campaign during a campaign in 1973 cost $200,000. The price tag for a 30-second ad slot in 2007 was $3 million. That's probably exponential growth over many years. The cost of a 30-second ad slot can be modeled by this equation. Okay, so there's an equation. It is exponential growth. Okay, there it is. X is the number of years after 1900. You gotta pay attention to those words, so that's key words. So now what do they want? What's the cost in 2005? Well, if X starts in 1900, then 2005, X would be 105 years. So I would, 2005, X is 105, and that's because of what they said here. So I would plug in 105, huh? And just do the math. Use my calculator. 1.102 raised to the 105. I mean, that's confusing in itself. And then after that, it's multiplied by 0.0000967. Wow. Anybody want to tell me an answer for this one?
259.7.
Okay, 259. Now let's say they round to the nearest dollar. So you said 0.7. So maybe I'll call it 260. 260. Oops. Was it 260 million? Maybe that's the answer. Yeah, it's in millions. So I better put in millions. 260 million? Wait, did you do that right?
Is it 2 point something?
Yeah,
It's probably 2.59 million.
131.25.
Oh, okay, hang on. Okay, so what's the answer your calculator tells you? 2 point?
Yes. 2.59.
Okay. And that you might, if you don't have enough zeros here, or if you, yeah.
Yeah,
Okay.
I think I'm correct.
All right, cool. So 2.59, that's the answer. And so that's 2.59 million is what that is.
Want you to know the rest of the decimal?
And what's the rest of the number?
'Cause it wants to-
2,597,131.25.
Okay.
7.
All right. Say, tell me how. All right. So
But
it's
this one sucked.
2 million. Say it again.
597,
All right.
131.25.
All right. So I'm rounding to the dollar. I'll call it 131.
Yep.
Fantastic. But your calculator said 2.59, and that was 2.59 million. So you had to move the decimal all the way over and keep track of those decimals to get it to the nearest dollar. Yeah, what a pain. Nah, I don't want to do that. All right. Similar thing maybe here. Yeah, solving. Oh, here's some good stuff here. Yeah, this is good. Look, you guys. This is kind of difficult. So now I'm solving a logarithm equation. You know, you guys had one on your quiz. We took a quiz the other day. I want to show you something. We took a quiz the other day, and you had this question. And you were supposed to solve for x. It was the last question. I'll give you those quizzes in a minute. It was the last question you were supposed to solve for x. And a lot of you didn't do a very good job. Listen, my directions for solving a log equation are to rewrite it. That's my idea. I mean, there might be a different idea that works better for your brain, but I'm saying you rewrite it. And that means you start with, you can rewrite it in exponential form. There is a base staring right at you. It's the base of the logarithm. It is 5. So 5's the base. And then if it's a base, it has an exponent on it. And the exponent that goes on it is over here, which is the 3. So it's the base raised to the exponent equals what's inside the logarithm. So when you rewrite it, you now have a very easy problem. So that's the key, is that beginning step. Otherwise, if you don't have the beginning step, you go nowhere. But if you rewrite it, you now have a real easy problem. This is 125 is what it is. And you, so this was on your quiz, and you proceed to solve for x. Now this is a hell of a lot more complicated version of that. This is more complicated. I mean, and what I want to do is I want to get here. If I can get here with one log equal to a number, then I can do the rewrite thing. Well, they got logs all over the damn place, and it's pissing me off. Let me help you here. I got this 2 log x equals this log of 6x minus 90 plus 1. Oh my goodness. See, I want my logs together. So I think I want to subtract this log over to this side. And then I'm thinking about, I'm subtracting logs, and that makes me think of my properties of logs. If I'm subtracting 2 logs, I can write that as a division. Now, I'm a couple steps ahead of you, so hang on a second. But that's those properties of logarithms. One of the other properties of logarithms was, if you have a number multiplied in front of the logarithm, you can move it up and put it up here, and it's an exponent. So I want to do that move too. So here I go. I'm moving the 2 up and calling this the log of x squared. And that's a special property of logarithms that we discussed sometime. And I'm also moving this log over, so I'm subtracting the log of 6x minus 90. And I'm leaving the 1 over there. So you guys follow me on that? I use this property of logs and I move this log over. Now I have the subtraction of 2 logs. I can write that together as the log of a division. I can write that as the log of the x squared over the 6x minus 90. That was one of my special properties of logs. And it equals 1 on the other side. See, that's tricky. There's not too many of these. There's probably just one of these. Where you have to really work with those properties of logs. But now you're in a good place. You got 1 log deal equals a number. And you can do like I did a second ago. Rewrite the log. But you have to start with the base. And what is the base right here?
10.
Thank you. Thank you, thank you. It's base 10. And so how do I rewrite it? If this is base 10, I'm going to write 10 raised to the 1th, or first, equals what's inside the log, which I know is a little nasty, dude. It's a little nasty inside that log. But we took a complicated log equation, gathered the logs together using log properties, rewrote it, and now we got an algebra problem, which you may or may not know how to finish. But we went from chapter 5 to chapter 3 here. So, because it's a quadratic equation here, any suggestions? Yeah, you got to get this crap out of the denominator, right? You got to multiply it by 6x minus 90. And so you're multiplying it, it comes up on this side times the 10. You get 60x minus 900 equals x squared. You guys with me? Multiply by the 10. Hey, now it's quadratic. When it's quadratic, I want to move everybody on one side and make it equal to 0. So I'm going to subtract negative 60x plus 900. You know what I mean? Move those over there. Get it equal to 0. Hey, now maybe I can factor it. $30 and 30. Dude. X minus 30, x minus 30, baby. Which means there's not really 2 answers. There's kind of 1 answer. What is it?
30.
30. Woohoo! That was fun. Yes, ma'am.
Okay, what did you do with the 1?
Well, what did I do with the 1? I left it sitting right there for a while. I left it there for a while. I left it there for a while. But now I rewrote the logarithm. So it's 10 raised to the 1st power. See that what the 1 is it's the answer to the logarithm. So it's the exponent that goes on this base. So it was 10 raised to the 1st power. There's the 1. had to move over here, sorry, move around a little bit.
Wait, isn't it 90? The 900?
Uh-huh. It's a 90.
You wrote 6x minus 900.
Yeah, 90. No, it's 90, and then I had to multiply this up here. I had to multiply this over to the other side using some algebra. So then I had to distribute the 10. So 10 times 6 is 60, and 10 times 90 is 900. Yeah, I distribute the 10. Yeah. It's good stuff, good stuff. Let me, See, here's another one. Look, here's one more here. And then I got some other things I got to talk about, but here's one more of these. And maybe you can read it, and I'll blow it up for you. 2 plus 3 ln x equals 26, right? And at least this time there's just one log, but I do want it by itself. So what do you want me to do? Tell me. Subtract 2? I got you. I'm subtracting 2. Just like good old algebra does, right? And so this is 24. Sorry, that's an X. All right, now what? You want me to do anything else?
Move the 3 to the...
Yeah, divide by 3 is a smart idea. Divide by 3. So now you really do have the log all by itself, and it equals 8. Now, to get X, I suggest you rewrite the log. In order to rewrite the log, you identify who's the base. Who is the base? E. And when you rewrite it, you start with the base, E, and the exponent that goes on E is right there. So the answer is E to the 8th equals what's in there, which is just an X, and we're done. And if you notice, they don't even want me to pick up my calculator. I mean, E to the 8th is some huge number, and you could do that. You could round it off, but they actually say, please type in an exact answer using E. So they want you to type in E to the 8th. That wasn't hard. You gotta kind of know your way around logarithms. You gotta know some stuff. I'm quitting this. Earlier today, he said he had a quiz question. I wonder if I could take a look at this quiz quickly. We have a Chapter 5 online quiz out there.
Number 20.
Okay, I'm gonna flip ahead to number 20 to answer his question. Let's start with this one though real quick. Can you tell me whether this is growth or decay? It's a little confusing. Earlier this morning, I almost screwed this up. But growth and decay shouldn't be too hard, but I got myself confused this morning. Listen, what's the base? 6. Okay, if the base is bigger than 1, it should be growth. If the base is less than 1, it should be decay. Now, there is one exception to that. If the base is bigger than 1 and you got a little negative sign up there on the X, that makes it decay. But anyway, with a base of 6 and a little 0.1x, I mean, this is growth. With a base of 6, it's growth. What's the next one? What about that one? Growth or decay? Because of the little negative sign. Makes it decay. Yeah, good. All right, there's some other stuff here. He just asked me about 20. Let me just jump up here.
Drop down about whatever hour you can get to 20.
Yeah, maybe I could. I'm there now. Now I'm there. Yeah, that's kind of what we just did. Some stuff. Ooh. Okay, let's see what this is. Make me read. He's going to make me read. The consumption of electricity is modeled by this. Okay. A is the current use. R is the rate at which its use is increasing. And T is the number of years. Suppose the consumption of electricity grows at a 3.3% rate per year. Now, hold on. I think that's my rate. They didn't use the word rate. I did. But I think that's my rate. Do you agree?
Yeah.
Okay. Then find the number of years before the use of electricity has tripled. Oh, I see what you mean. This is a good question. See, you know what's funny? So I got this formula. C equals A e to the RT. By the way, it looks like some scary new formula. You know, it's the same old formula. Maybe you guys should realize that. I know when we do our compounded continuously interest, we use this formula, but with different letters, it's the same formula. Right. And that was true with the radioactive thing. That was true with a lot of these. This is kind of the formula. But this is kind of cool. See, they gave me that rate, but they didn't give me a starting value. They did not give me a starting value. But they asked me how long it takes for that starting value, whatever the hell it is, to triple. So watch how I do this. I'm pretending I got an unknown starting value of A, but if I want it to triple, then what will it be? It'll be 3A. So watch this. So I'm going to plug in a 3A over here. So now I have this. What's my little, I got to put in my little R. That's a 0.033. Do you agree with that? And then you look at this and you say, well, I'm supposed to solve for T. And you might say to yourself, well, I got too many, I don't know A, I can't solve for T. But what's the first step?
Divide by A.
Divide by A. And if you divide by A, you'll realize you don't need A. It cancels away here and it cancels away here, and you can solve this problem. Are you following me? I mean, usually they give me a number and then they give me a number I'm shooting for. This time I didn't know the starting number, but they said triple it. So I tripled it. And even though I didn't know it, I didn't need it. I mean, how do I finish? You guys, I mean, I'm happy. I feel like I'm finished because I know I can finish, but I was happy when these A's canceled away because I thought I was confused a few minutes ago, like I had too many damn variables. But once these A's canceled away, I'm very happy. How do you finish? ln both sides. You ln this side. On the ln of this, it kills the E and leaves you with this. One more move. Divide by the 0.033 and you get an answer. It'll be the number of years. It'll be the natural log of 3 divided by 0.033. Anybody want to tell me what it is? 33.29? Cool. At least it's up there. All right. That was fun.